Find the HCF and LCM of 124 and 125. First, don't start with factorizing. Look at the relationship between the numbers 124 and 125 are consecutive numbers. The HCF of any two consecutive numbers is always 1. Since their HCF is 1, their LCM is simply their product. So the answer is HCF is 1 and LCM is 124 into 125, 15,500. Now it's your challenge. Find the HCF and LCM of 198 and 199. Find the HCF and LCM of 47 and 59. Both numbers are prime and they are different. A prime number has no factors other than 1 and itself. Since 47 cannot divide 59 and 59 cannot divide 47, their only common factor is 1. Therefore, HCF is 1 and LCM is simply their product. If HCF is 1, LCM is simply their product. Now it's your challenge. Find the HCF and LCM of 61 and 73. Find the HCF and LCM of 84 and 125. First, look at the relationship between 84 and 125. They are known as co-prime numbers. It means they don't have any factor other than 1. So, if a number having only 1 as a common factor, that is known as co-prime numbers. Co-prime doesn't mean both numbers have to be prime. That is important point. 84 and 125 have no common factor other than 1. Therefore, their HCF is 1 and the LCM is simply their product. Now, it's your challenge. Find the HCF and LCM of 121 and 144. Now, shortcut number 4. Find the HCF and LCM of 72 and 360. Look at the relationship. 360 is exactly divisible by 72. Whenever one number is an exact multiple of the other, the smaller number is the HCF and a larger number is the LCM. No prime factorization is required for this kind of problems. Now it's your turn. Find the HCF and LCM of 96 and 768. Shortcut 5. Find the HCF and LCM of 29 and 203. This is actually a special case of shortcut 4, but it is useful for competitive exam pattern recognition. Here the smaller number is a prime and the larger number is its exact multiple. The moment you recognize the relationship, you don't need to factorization. The prime number is HCF and the multiple is LCM. Now it's your challenge. Find the HCF and LCM of 31 and 248. Find the HCF and LCM of 84, 168, 252 and 504. Here I want to notice you something. The largest number is 504. Is exactly divisible by every other number 84, 168 and 252. Therefore, without calculating LCM, we know immediately the LCM is 504. Next, HCF. First, consider the smallest number 84. Here 84 divides the every other number 168, 252 and 504. So HCF equal to 84. If the smallest number divides every other number, HCF equal to smallest number. If the bigger number is divisible by other number, LCM equal to largest number. Now it's your challenge. Find the LCM and HCF of 72, 144, 216, 432. Now shortcut number 7, extremely useful for LCM. The HCF of two numbers is 1. The numbers are 143 and 160. Find the LCM. Okay, whenever the HCF of two numbers is 1, don't waste time to finding the LCM by listing the multiples. Okay, their LCM is simply the product of two numbers. Now it's your turn, your challenge. HCF of 221 and 288 is 1. Find their LCM. Now the most important two-number formula. The HCF of two numbers is 24 and their LCM is 720. One number is 144. Find the other number. Here is a very useful shortcut for HCF and LCM questions. HCF into LCM is equal to first number into second number. This relationship is always true for two positive integers. Now substitute the values. 24 into 720 equal to 144 into x. We know that HCF is 24, LCM is 720 and one of the number is 144. The other number is we have taken as x. X equal to 24 into 720 divided by 144, which gives 120. So the missing number is 120. This formula works for every pair of positive integers. No factorization is necessary for these kind of questions. Now it's time for challenge. HCF is 18, LCM is 630, one number is 90. Find the other number. If you found this video helpful, please like and subscribe and don't forget to share with your friends.